Yeah, good evening all. Now I am going to explain about introduction to AC circuits. Okay, before going to discuss about AC circuits, first what is the difference between AC circuits and DC circuit? Okay, DC circuit is nothing but the magnitude of voltage or current is constant with respect to time. That is nothing but a DC circuit. Okay, whereas in case of AC circuit, the magnitude of voltage or current alternatively changes. Okay, the magnitude of voltage or current alternatively changes. That means, for example, let us consider a single phase AC supply. That means voltage will be 230 volts, right? The magnitude of voltage is varies from 0 to 230 in positive direction, 230 to 0. Again 0 to 230 in negative direction and minus 230 to 0. Okay, AC waveform is having positive half cycle and negative half cycle. That means the magnitude of voltage and current is alternatively changes, but practically we didn't identify this change, right? The reason will be frequency. Indian standard frequency is 50 Hz, that is equals to 50 cycles per second. Now see here, cycle is nothing but the complete set of positive quantity and negative quantity is known as cycle. That means for every 1 second 50 cycles will be repeated. That means 100 half cycles are repeated, right? That means that variation our eye pointer didn't identify. Okay, that is nothing but AC, that is about AC voltage. Okay, next coming to some basic definitions in case of AC voltage, right? This is the representation of AC voltage or sinusoidal voltage. Okay, this is the waveform of a sinusoidal voltage. Okay, this is nothing but amplitude. Highest value of an alternating quantity is nothing but amplitude. Okay, now see here, AC waveform is having positive cycle as well as negative cycle. Total time period will be 2 pi seconds. For half cycle, time period will be pi seconds. Again in this half cycle, half period will be pi by 2 seconds. Pi by 2 is nothing but 90 degrees, pi is nothing but 180, 2 pi is nothing but 360 degrees. Now first definition is waveform. Waveform, this is the waveform, right? That means it is the graph drawn between instantaneous value of voltage or current versus time is known as waveform. Okay, sir, what is meant by instantaneous value? See here, instantaneous value is nothing but the value of an alternating quantity at any instant of time is known as instantaneous value. Okay, the representation of instantaneous value is V is equals to Vm sin omega t, current I is equals to Im sin omega t, where Vm is maximum voltage, where Im is maximum current. That means, see here, what is meant by instantaneous value? The value of alternating quantity at any instant of time is known as instantaneous value, right? See here, from this equation, substitute omega t is equals to 0, sin 0 0, right? Then at this instant the value will be 0. When omega t is equals to pi by 2, that means 90, right? Sin 90 value will be 1. That means V is equals to Vm. This is the maximum value. Okay, that means at omega t is equals to pi by 2, V value will be Vm. That means the value of an alternating quantity at any instant of time we can calculate it, right? That is nothing but instantaneous value of voltage or instantaneous value of current. Okay, next, cycle. See here, cycle is nothing but the complete set of positive quantity and negative quantity is known as cycle. Okay, the complete set of positive quantity of an alternating voltage and negative quantity of an alternating voltage is known as cycle. Okay, this is the representation of cycle. Next, from this waveform only, time period. Okay, this is the time period. Time taken to complete one full cycle is known as time period, or the repetition of waveform is known as time period. Okay, now see here, from this instantaneous value omega, here sin omega t, right? Omega is nothing but angular frequency in radians per second, where omega is equals to 2 pi f, where f is frequency, omega is angular frequency. Here units will be radians per second, for frequency units will be hertz. Okay, next definition is alternation. Alternation is nothing but The half cycle of an alternating voltage or current is known as alternation. See here, this half cycle is known as alternation. Okay, next, time period. Time taken to complete one full cycle is known as time period. Next, frequency. Okay, see here, frequency is nothing but number of cycles generated in 1 second. Okay, this is one cycle, right? For Indian standard frequency is 50 Hz, right? That is 50 cycles per second, right? That means frequency is nothing but the number of cycles generated per 1 second is known as frequency. Okay, which is denoted by F. Units for frequency will be Hz. 1 Hz is equals to 1 cycle per second. Indian standard frequency F is equals to 50 Hz, that is 50 cycles per second, whereas in American standard frequency F is equals to 60 Hz. Okay, here the relation between time period and frequency is time period T is equals to 1 by F. This is the relation between time period T and frequency F. Okay, next coming to amplitude. See here, amplitude is nothing but the highest value of an alternating quantity either in positive half cycle or in negative half cycle. Okay, negative half cycle highest value will be minus Vm, right, from this waveform. That means the highest value of an alternating quantity either in positive half cycle or in negative half cycle is known as amplitude. Okay, V is equals to Vm is highest value in case of voltage, I is equals to Im is highest value in case of current. Okay, from the instantaneous value of voltage, okay, V is equals to Vm sin omega t. Already we know that omega value will be 2 pi f, right? That is V is equals to Vm sin 2 pi f into t. Already we know that t is equals to 1 by f or f is equals to 1 by t. Then this equation can be written as V is equals to Vm sin 2 pi by t, capital T into small t. Okay, that is again V is equals to Vm sin theta. Theta is equals to omega t. These are the ways to represent instantaneous value of voltage. Similarly, current also. I is equals to Im sin omega t. Okay, that is I is equals to Im sin 2 pi by t into small t. That is I is equals to Im sin theta. Okay, next, from these basics, just we will solve one problem. Okay, the instantaneous value of current I is equals to 14 sin 314 t. Okay, determine first bit maximum current, second bit frequency, third bit time period. Okay, now see here, what is given, current value is given, right? I is equals to 14 sin 314 t. Now you can compare this equation with standard equation, that is I is equals to Im sin omega t. If I compare with standard equation, here Im value will be 14, omega value will be 314 radians per second. Omega is angular frequency. Okay, that means what is the first bit he is asking? Calculate maximum current, right? Here maximum current value will be 14 amperes from this comparison. Next, omega is equals to 314 radian per second, but we need to calculate frequency. Okay, he is not mentioned anything, means frequency in hertz we need to calculate that one. Okay, already we know that omega is equals to 2 pi f. 2 pi f is equals to 314, then f is equals to 314 divided by 2 pi. If I simplify this equation, I will get frequency value as 50 hertz. Okay, after that, time period t. Time period t is equals to 1 by f, that is equals to 1 by 50, that is equals to 0.02 seconds. If I convert into milliseconds, multiply and divided by 1000, right, you will get 20 milliseconds. Denominator 1000, you will get to numerator, that is 10 to the power minus 3, that is nothing but milli. In numerator 0.02 into 1000, you will get 20, that is 20 milliseconds. Okay, these are some basics about AC circuits. Remaining we will discuss in next class. Okay, thank you all.